Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about the medium problem swap nodes in pairs of the daily LeetCode challenge of day 16 of February. Okay, so yeah, this problem is totally related to a linked list and we need to perform the operations efficiently. Like we need to do we need to use a O of one space in the best way to swap the nodes that are adjacent in a linked list. Okay, so we will deal everything. For now, let's look out for this similar question section first. You can see there are two more problems: swapping nodes in a linked list and reverse nodes in a k group. So like if you feel that this problem swap nodes in pairs that I'm going to discuss now is a little bit harder for you to solve, or you are unable to solve it, I would suggest you to go over this problem swapping nodes in a linked list. First solve this problem, and yeah, after that then you should come for this problem swap nodes in pairs. Like if you look out my submissions, yeah, I didn't have any submissions. I don't know. Yeah, maybe this problem seems very much easy to me. But yes, this hard problem reverse nodes in K group. I have already solved this problem. Yeah, you can see it was for around month of July previous year, and yet I solved this problem right now over again. Okay, so I've already told you the sequence through which you are going to solve this problem is like swapping nodes in a linked list. You are going to solve this one first, then go come over this problem swap nodes in pairs, solve this one, and after that you're going to solve for the general case, that is reverse nodes in k group. In this problem we have been given k as 2. We need to reverse the nodes in a group of 2. Okay, and all over that, if you're stuck on any of the problems, you can find all the solutions to this problem in my playlist. You can see playlist that is totally containing the problems of linked list. You can see reverse nodes in k group is already posted. Okay, and also there are all the problems like linked list cycle second one, and also you can see this one also swapping nodes in a linked list is also present. Swapping nodes in a linked list, one traversal, constant space. I have told everything, so if you guys have still any doubts, then you can go over there and check it out. Okay, so let's understand this problem, how we are going to do that efficiently. Okay, so given a linked list, swap every two adjacent nodes and return its head. Okay, so we need to swap every adjacent node that is present in the linked list. You must solve the problem without modifying the values in the list nodes. That is, only nodes themselves can be changed. Okay, so it like you may solve this problem like swap the value that is present in the node 2, like node with value 2 and node with value 1. Okay, swap these values, then you are going to get this one. This is, yes, you can do that, but we are not allowed to do in this problem, right? So we need to actually swap the node's position, right? So we need to actually swap these node positions to the respective places. Okay, how we are going to do that? So I'm going to tell you the efficient approach. First, let's look over the constraints. The number of nodes in the list is in the range from 0 to 100. So we need to manage the base cases also. Like if there doesn't exist any node, like the length of the linked list is 0 or length of the linked list is 1, we need to manage that case separately, and then we are going to do that for the general. Okay, so let's understand this entire thing with the help of a small example. So I will take this example 1 2 3 4, right? Okay, so to be more efficiently, what I am going to do is I am going to just take this one, extending it to two more nodes, 3, then goes to 4, then goes to 5, then goes to 6. Okay, so this is actually, let's suppose we have this linked list, and yeah, what would be answer if we reverse every two pairs? Let's try to figure it out. You can see if we reverse it, it would become 2 2 to 1, and when we reverse 3 and 4, it would become 4 to 3, and when we reverse 5 and 6, it would become 6 and to 5, right? So let's join these pairs, 1 to 4 and 3 to 6. Okay, so this is our answer, and this is our original linked list. So the very important thing, like like how I solved this problem is by observing the how the positions of nodes is going to move. So I would strictly recommend you that you should also observe the pattern, observe how the nodes are moving and where the nodes are going to be placed to its new positions. Okay, so the very tricky way or the very first way to do this problem is to consider every pair. So this is important. So you should always look out for the pair. Like when you are doing one operation, you should always consider this pair. Club it into a one node. Let's suppose for an instance, and also you are going to consider this as a one substance. Like you're always working upon a pair, and similarly for this one. Okay, now what I'm going to do, let me talk about the general case. Like we would be saying for that we are working on this pair. We are working on this, working on this. Like this pair, this is the pair that we are working upon this. Now let's suppose that yes, previously like the previous value 1 and 2 is already at this position, like we have already done this operation. Now we are working upon this pair. Okay, now let's understand how this movement is going to be done. Okay, so yeah, so let's say that this node, like this node 1 is storing the address, not saying it like that because it may confuse you. So let's say we have the variables like node variable, node values. Let's say we have values previous, tail. Let's say we have the node called previous tail that is going to store the node address of the previous group, right, and its tail, right. So if this is the, like if you're working upon this group 3 4, then previous tail would be the node address of this one, right, because we have already swapped 1 and 2, it would become 2 and 1. So previous tail will store the node address of this one. Okay, and we are at the current node, this one, this should store curr, which is the current node, and this is the previous node, and the previous tail would be this one. Okay, so yeah, so we need to understand how the nodes are going to be moved. So previous tail would be here, previous would be here, and current will be here. So we are going to work the reverse this linked list in a groupwise order of 2 efficiently with the help of 3 variables. Previous tail, that will always store the tail node of the previous group if you're working on the current group, and previous will store the very first node of the current group, and current will store the second node of the current group. Okay, I hope the entire thing would be clear up to right now. Okay, now let's try to understand how the movements are going to be done. You can see that previous tail is going to be linked with this current node's address. Okay, so what you are going to do is like you are going to assign previous tail next pointer is exactly equal to the current pointer. Okay, now you have already assigned this current pointer, and now, so okay, so current pointer next would become previous pointer. Okay, so if you're not understanding, not getting it right now, no need to worry about. You can see the node with 1 is assigned with node with 4, and now the 4 is going to be contained in the current node address. Current is the variable name, right, node's name. Okay, and yeah, when you are going to link with this one, previous tail next would be this current. You can see the actually this current next is was 5, but now current next is 3, and 3 is being stored in the previous variable, right. So you are going to assign current next as previous. Okay, and one thing also, like since you are modifying the value of this current next, you can see, so first of all you need to store this node's address of this 5. So initially you will make a new node next underscore node, and you will assign it as current next, because you need to iterate in the linked list obviously. So you need to know the next pointer and store it. So you will first store current next, okay, and then you will assign previous tail next as current and current next as previous. Okay, now you can see that this entire thing, okay, so let me first change out the color because it may confuse you. Okay, now you can see that you have already done this part, and you are already swapped this one like 4 and 3, and you have made the like you have joined these two groups, 1 to 4, 4 to 3, right? And now the next thing is you need to also join the with the next group. You can see you need to join 3 to 5 first. Okay, because now you can see here it is 3 to 6, but yeah, this is the final linked list. For now you are done with this entire part. Okay, so when you have swapped this one, so 4's next would be 3, and the next thing that you are going to do is you need to join 3's next as 5. Okay, so what you are going to do is you will write down, you can see 3 is contained in this previous variable, so you will write previous next. And what is the node address being stored for the value 5? Which node is going to store that? It is going to be stored in the next node, so you will write next node. So previous next would be the next node. Okay, now you can see entire thing has been done. You have already done these entire operations, like this is entirely linked. Okay, now you need to move to the next group. Obviously you need to move to the next group. So as you move to the next group, you need to assign the values of previous tail. You need to assign the values of this previous tail as well as the previous value to their original meanings. Like what is the significance, what is the meaning of this previous tail? It will always store the node's address of the previous group, and that node which is actually the tail node, right, of that group. And what is the value, what is the meaning of this previous node? Prev node is actually the very first node of the current group. Okay, so let us assign that. You can see previous tail is at the, like when you are at this position working on this group, previous tail is at this position, but when you are done with this group, your previous tail should point for this node 3, right? So what you are going to do is you are going to assign previous tail is exactly equal to the previous. And why you are going to do that previous? Because previous is storing the value, previous storing the address for the node with value 3, right? And the next thing that you are going to change is the previous variable. Previous variable will be changed to the next node. Okay, so previous value changes to the next node, and next node is actually storing the node address of for this node with value 5. Okay, again you need to change the meaning of this, like you need to move this current pointer to the next node over here. How you are going to do that? Okay, so the current pointer will move to the, you can see the next node is storing the current next, which was this node 5, and you need to move to its next node, so it will move to the next node next. Okay, so yeah, there might be the case that you have done with the linked list, like entire linked list has been exhausted, so you need to do the operations efficiently. You need to do this one only and only when next node is not equal to a null pointer. Okay, so entire thing has been done. So let's move out to the coding part and understand how this entire step-by-step operations is going to be done, and along with I will tell you how this linking of the nodes is going to be done efficiently again one more time to make your concepts very much clear. So let's move out to this coding part. Here I have submitted two codes, and yeah, this second code is actually the generalization of this problem, like reverse nodes in k group, and in that problem we are going to do that for a group of size k, and here it is the group of size 2. Okay, so we are going to do like we can do that like for k equal to 2, putting k as 2. You can see I've done like putting k as 2 and solve this problem. But for now let's try to understand this how we are going to do by considering only adjacent nodes, which is a group of size 2. So let's try to write the general case first. If head is a null pointer or heads next is a null pointer, it means that the total number of nodes is strictly less than 2. Then we are going to return the head node of the linked list. That will be our answer. Okay, so let's find out first the new head. Okay, let's assign new head as null pointer, because yes, when you want to reverse this only the very first group, you can see new head becomes this node with value 2, like node's address with value 2. Okay, so you need to do that also, like your head of the linked list will change. Okay, so let's take our current as head next and previous as head, and previous pair tail, like previous group tail would be a null pointer, as I've already said. When let's say we are working on this one, okay, so your previous would be the first node in this group, and the current will be the second node in this group, and previous tail would be the tail node of the already reversed linked list, which is just beyond this group. And yeah, it will be a tail node, like you can see it will be this node for the previous group, and this is actually a reversed node, already reversed. Okay, so let's iterate till current is not a null pointer. So first I will take out the next node. As I've already said, next node will be the current next, because you need to move further in the linked list, so you need to store the address for the next node. Okay, and also you need to change this 4 pointer to the 3 pointer, and only this can be happened when you store the address for the next node. So if new head is a null pointer and that is it is still not yet assigned, it means that you are in the very first group. Okay, that is you are working on this very first group. In that case, your head will become the current variable. You can understand, because previous would be over here and current would be over here. So when you reverse it, current becomes the head. So you can see I have assigned new head as curr, which is the current node address. And if this doesn't happen, it means that new head is already assigned. It means that you are working on that group number which is strictly greater than 1, that is the second group or the third group or so on. Okay, in that case you need to link these two groups, and this can be efficiently done by writing only single statement. You can see previous pair tail next, that is the, you can see this next would be the current one, which is the 4. Previous pair tail next, which is the current one. Otherwise join the previous pair tail with the current pair, as obvious. Okay, now this is done. We need to move out to the next group by assigning these values. Okay, so how we are going to modify these values? You can see current next and previous pair tail both becomes the value, both will be assigned with that node address which is stored in the previous. Okay, so let's understand that. So you can see 4 becomes 3, right? 4's next would be 3. 4 is going to be, like you can see, this is actually a node with value 4. Current will store that, and its next would be 3. And when you move out to the next group, you can see this is entirely reversed, that is 3 4 becomes 4 3. Okay, and the previous pair tail would be at this position. You can see current next would be storing the node with value 3, node's address with value 3, and also previous pair tail will also store that node address with value 3. Okay, that is, you can see I have assigned both to the previous, that is node's address stored in the previous variable. Again you can see you need to modify this previous, so previous next would become next node, that is 3's next would become 5, because you need to move on to the next one. And also previous will change and it would become next node, because when you work on this group, current would be over here and previous would be over here, so you will move out to the next node. And yeah, if next node is a null pointer, that is, suppose you are also done with this group, so you will see next node would be a current next, so it would be a null pointer, or next node's next is a null pointer. It means that the total length of the linked list is going to be odd. You will always end with the last group having the size as 1. So in that case you are done, so you need to do a break, otherwise you will move current as next node's next. That is what I have been doing over here. Okay, and finally return the new head, which will be your answer. Okay, you can also generalize this one, like I have also submitted this general solution for k nodes group. K size of the group is k, size of any group is k, so I put it k as 2, and this was actually the same solution that I have been used in reverse nodes in k group, where it would be a size k. Yeah, it would be of size k. You can see here it is actually the, you'll be given the size k. Okay, so but yes, I have put it k as 2 and the entire process is same. Okay, so if you guys have still any doubts, do tell me in the comment section of the video, and thank you for watching this video, and do not forget to subscribe.